Okay, I'm going to show you guys how to work through the lottery problem here. And the first thing that you want to do is, of course, find x times p of x. So I'm going to open this in StatCrunch. And we've got the cash prize and the probability of getting the cash prize. So we're going to build another column called x times p of x. So let's click on Data, and then we'll compute expression, and then we'll build it. So we'll add x, and then multiply times p of x, and add that, and then OK. Now you can add a label here, and we'll just add the label x times p of x. Okay, so what that does is multiply each of these, this times this time. And now we just want to add this up because the expected value is the sum of x times p of x. So we'll go to Stat, Summary Stats, Columns, and we want the sum of x times p of x. Okay, so we see that the expected value is 28 cents. Okay, you will win 28 cents on no. On average, you will win 28. On average, you will profit. Well, we haven't talked about profit yet, but profit takes into consideration how much it costs to play. So this just says we're going to win on average 28 cents. Now we'll do the expected profit. And the expected profit is going to be the expected value, 28 cents minus $1. So that gives us 72 cents. And it's actually negative, because we're losing money. We're paying $1 and we're expecting to win 28 cents. Okay, and so this one here gives a lot of students trouble. It says, to the nearest million, how much should the grand prize be so that you can expect a profit? So the grand prize here, we're asking how much should that be to expect a profit. So that's kind of unknown. And it was, what did it start out to be? Something like 13 million. What did we get over here? Yeah, 14 million. So it should go way up. And here's the idea. What we want to do is we want to take the expected value minus the cost and set that equal to 0. Okay? And that gives us an even game. And then anything over that, in terms of expected value, would give us a profit. Now remember, the expected value, this guy here, is no longer 14 million, but it's saying what should this be? So we'll just let it be x. So then we've got x times p of x, and then x times p of x, which would be a number, x times p of x. So the first term in this expected value is going to be x times 8.14 times 10 to the minus 9, and that's what the E means. Okay, and then plus the next term here, plus this one, 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 plus this one. And all of those will be numbers, okay, because this is a number, and this is a number, and this is a number, and this is a number, so on and so forth. But this first one here is going to be unknown. So let's go ahead and add up all of these yellow numbers here. And if we do, we get 0.166112. Okay, minus the cost, which is $1, is equal to 0. Okay, so let's go ahead and do a little simplification here. So we get x times 8.14. And then we're going to go ahead and do the arithmetic here. So 0.166112 minus $1 gives us minus 0.8389 is equal to 0. Now notice something here. This equation here is really like the equation x times a minus b is equal to 0. So that's really the equation that we're solving. And you can see to solve this equation, you just need to add b and divide by a. So x is equal to b over a. Okay, so we've got x times a minus b is equal to 0. So when we solve this equation here, we get that x is equal to 0.83389 divided by 8.14 times 10 to the minus 9. And that's actually, don't leave off that, times 10 to the minus 9. That number's there. Okay, so let's go ahead and see what we get here. And I'll go ahead and pull up our calculator here and show you how to do this on the TI-84 Plus calculator. So we're going to take 0.83389 and divide that by 8.14, and then the double E here, second comma, gives you the times 10 to the minus 9. And then we'll enter. Okay, now we get this number here, 102. To the nearest million, we've got a comma here and a comma here, is going to be 100. Now, what you want to pay attention to is that this number here, no matter what this decimal is, we're always going to round up to the next nearest million. Because remember, this is the exact grand prize that will give us an even game. But we want to know what's a profit. So if we knock off even this 9 here, we're going to be losing money. So we need to round up. So even though this is a 4, we're still going to round to 103 million. So let's go back over here. 103. One, two, three, 4, 5, 6. Okay. So does the size of the grant affect your? No, the chance of winning is solely based on the properties of the lottery, not the payouts or anything like that. Okay, hope this helps with the lottery problem.